Well, today I'm going to make a wireless power transmission, a small one, to replicate the wireless charging that Apple and Samsung uses for their phones, and some electrical toothbrushes also use that wireless charging. So there are quite a few videos on YouTube which tell how to make the wireless power transmission. I'm going to be explaining how this works as I make one. I will be using minimum basic items to make a small wireless power transmission to demonstrate how it works. More complex circuits can be created, but they require more items which are difficult to get for a small DIY project. Wireless power transmission works because of the magnetic field that is created when the current is passed through a conductor, which in this case is a copper wire. A small straight wire produces circular loops of magnetic field around it along its entire length through which the current is flowing. Now if I make the loop into a circle, then the magnetic field will look like this. The maximum magnetic field will be in the center of the loop. So let's make this now. I will use a small LED, a green one, 2.2 volts, which will light up wirelessly when the wireless power transmission circuit is used. So the items needed to make this wireless power transmission circuit are a small LED bulb, 2.2 volts. I'm using a green one, a transistor, 2N2222A. I'm using CPT2N2222A. To strengthen the magnetic field, a resistor, 470 ohms resistor, to allow safe current through the transistor so the transistor does not burn, 0.8 millimeter or 20 gauge enameled copper wire. Enameled copper wire is insulated copper wire, so we need that, about 10 meters long. AA battery, which is 1.5 volts. And a battery holder. If you don't have a battery holder, it's okay, don't worry about it. You can directly connect the wires to the AA battery using tape. And you will also need some wires and a soldering tool to connect the resistor, transistor, and LED to the copper wire. All of this will cost around $20 to $30 depending upon where you live. If you already have some of these items, then that is great. I'll show you the circuit diagram now so you get a better understanding of how the wireless transmission system works. So we need two circuits, a transmitter circuit and a receiver circuit. The transmitter circuit will transmit the power and the receiver circuit will receive the power. And this way the LED bulb will light up. If the two circuits are together, it means more voltage is being transmitted between the two circuits, and the LED will light up brighter and vice versa. The transmitter circuit takes DC voltage from the battery and then converts it to AC signal with a very high oscillation to produce the electromagnetic field. The receiver coil then converts this electromagnetic field to DC voltage and sends it to the LED, which turns the LED on. And this is how the system works. So the transistor has three legs. The outer legs are called collector and emitter, and the middle leg is base. For my transistor, CPT2N2222A, so if the flat face is facing me, then the middle one is the base. The right leg is the emitter, which will be connected to the negative terminal of the battery. And the left leg is the collector, which will be connected to the resistor, and the resistor will be connected to the copper wire. So over here, this is the emitter, and this leg is the collector, and this leg is the base of the transistor, and this is the resistor. So this emitter is connected to the negative terminal, collector is connected to the copper wire, and the base is connected to the resistor, which is then connected to the copper wire. So in this circuit, the two ends of the copper wire are connected to the collector leg of the transistor, and the other end of the copper wire is connected to the resistor, and the resistor is connected to the transistor. We also have to make a loop in the copper coil, which will be connected to the positive terminal to complete the circuit. Before starting the build, I will talk about why we need a resistor. Transistors have constant high voltage across them. Without a current limiting resistor, the current from the battery could be extremely high, which could destroy the transistor. The resistor ensures that the current flowing through the transistor is within safe limits and prevents burnout of the transistor. Transistor CPT2N2222A is designed for low to medium current, low power, medium voltage, and I'm using that transistor. This type of transistor is commonly used in switches and amplifying electronic circuits. Here it will act as a switch to control the flow of current through the transmitter coil. By adjusting the base current of the transistor, I can regulate the collector current, which in turn controls the amount of current flowing through the coil. When the transistor is turned on or is connected to the copper coil and the current is flowing through the copper coil, it allows a larger current to flow through the coil, resulting in stronger magnetic field being generated around the coil. Conversely, when the transistor is turned off or there is no transistor, the current flowing through the coil will decrease, leading to weaker magnetic field. By modulating the current through the coil using the transistor, I can control the magnetic field strength, which in turn affects the efficiency and the effectiveness of wireless power transmission. The datasheet for my transistor CPT2N2222A specifies a typical DC current gain of around 100 to 300, depending on the operating conditions. So for example, if I provide a base current of 1 milliamp and the transistor has a current gain of 100, then the collector current could potentially be amplified to 100 milliamp. And this is how the magnetic field strength is increased. But it is important to note that the actual current amplification may vary based on factors such as temperature, transistor biasing, manufacturing tolerances. Additionally, the transistor's saturation voltage and other characteristics will also affect the amount of current it can effectively control. And why do we need copper wire? Copper is a highly conductive metal, allowing easy flow of electric current. Its electrical conductivity surpasses most of the common metals, making it an ideal choice for transmitting electricity with minimal energy loss. Now the receiver circuit consists of a copper coil, and the two ends of the copper coil are connected to the two terminals of the LED. Doesn't matter which end is connected to positive, which end is connected to negative terminal of the LED, it doesn't matter. The longer leg of the LED is always positive, the shorter end is always negative, just for your reference. So this is the receiver circuit, which is very simple. So let's make the two circuits now, and you will get an idea of how resistor is connected to the copper coil and resistor is connected to the transistor and to the battery. To make the copper coil, I'm using this glass jar. It is 6 centimeters in diameter, approximately. So cylinder around 6 to 5.5 centimeter in diameter is good enough to make the coil. Use it to make the transmitter coil. So let's do it now. So grab one end of the copper coil, enameled copper coil, and then make turns. I will make total of 10 turns before I make a loop, and then another 10 turns after the loop. So total turns will be 20. So try making loops closer to each other. And how many I have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So after 10, what I will do is I will make a loop like that. And then I will keep going. 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So we've got 20 turns now. I will take this off of the glass bottle. So this is what I have. I've got two ends here and a loop, something like this. I will twist this around the coil so it tightens the coil. Over here also, twist it around, tighten the coil. And I can use a tape as well to further tighten the coil. So that is the transmitter coil. Now I will connect it to the resistor, transistor, and to the battery. Now because this copper wire is enameled, I need to remove the insulation so I can solder it and connect it to the resistor 470 ohm and transistor, which will be connected to the resistor and to the copper wire. And also I need to connect the battery wires to the copper wire as well. So what I will do is, you can simply use a sandpaper to remove the insulation from the two ends. I had already done it because I have used it to make a circuit before, but I will demonstrate this to you again. I will just use a sandpaper to remove insulation from the two ends and from the loop. So I think I've removed enough insulation. I will tighten this coil by just taping it together. You can use electrical tape as well. I mean, I'm using this white Scotch tape. This works also, just to make all the loops tighter. This looks like a nice tight coil, so that is great. I will make the receiver coil now. For the receiver coil, I will again use the same glass bottle and make 20 turns this time without any loop. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This tight coil. That's good. So this is the receiver coil now. Again, as I did with the transmitter coil, I will remove the insulation and enamel. I'll use a sandpaper. I will now connect the transmitter coil to the resistor, transistor, and to the battery. So this is the circuit. These are the two ends of the transmitter coil, and this is the loop that we have made, which is this one. So let's do it now. So I will first connect the resistor to the copper coil. I hate soldering these tiny wires and coils. I don't like it a bit. That's resistor done. Now I will connect the resistor to the base of the transistor, which is the middle leg. A tiny bit here. Should be okay. But this entire thing seems too long, so I will twist it again and then try to bring it inside. Just another loop. Yes. This is better. So now I will connect, as I mentioned earlier, with the flat face of the transistor facing me. The right leg is the emitter leg, which will be connected to the negative terminal of the battery, which is this one. And the left leg is the collector leg, which will be connected to the copper wire, which is this one. So I will connect it to the copper wire now, the left leg. Only need a tiny bit here. I don't like soldering tiny things here. And now I will solder the emitter leg to the negative terminal of the battery. So for the battery holders, the black wire is always the negative one, and the red wire is always the positive one. So the positive one will be connected to the loop, the negative one will be connected to the resistor. So I will connect the negative one to the resistor first, and now the loop will be connected to the positive terminal of the battery. So here is the transmitter coil circuit, or the transmitter circuit. Resistor is connected to the transmitter, and the resistor is connected to the copper coil on the other end. One another copper coil is connected to the collector leg of the transistor, and the emitter leg is connected to the negative terminal of the battery. And the loop of the transmitter coil is connected to the positive terminal of the battery, which is the red wire. So I will make the receiver circuit now. The LED needs to be connected to the copper coils. So let's do that. So I've connected the receiver coils to the LED. So this is the receiver circuit that is complete now. I will test how the power transmission is. So both of these coils have 20 turns, and they are 6 to 6.5 centimeter in diameter. This is the transmitter coil, this is the receiver coils. This should light up when I bring it closer. So you can see the LED lights up. If I bring it closer to the transmitter coil, move it away, its light reduces. Great, I'll turn the lights off. So you can see the LED lights up. Moving away from the center, LED light doesn't shine as bright. This way, this way, this way. So this shows that the magnetic field is strongest at the center of the transmitter coil. I will take a cardboard and I will use blue tack to put this transmitter circuit onto the cardboard. Let's see. Like this, and I will put this receiver circuit on another cardboard or whatever you have. I have this plastic strip, so I will use that. The LED lights up, which is great. So you can see I've turned the lights off now. So you can see if I move the two coils away from each other, the LED stops lighting. When I bring the two coils together, the LED starts lighting. And if I move the receiver coil away from the center of the transmitter coil, the light reduces until it stops lighting. So this proves that the magnetic field is strongest at the center of the transmitter coil. I made another small LED receiver circuit, a smaller diameter, just to see how smaller diameter impacts. So this is around 5 centimeter in diameter, but it only has 10 turns. This one has 20 turns, this one has 20 turns, this one only has 10 turns. So let's see how this fares. Okay. You can see this also lights up, almost as bright as the 20 turn, 6 centimeter diameter coil circuit. So I played around with different diameters and different number of turns. I think the key is that the transmitter coil should be of bigger diameter and a larger number of turns so that it can have a stronger magnetic field. So that magnetic field in the transmitter circuit induces voltage in the receiver circuit. So that's how this LED lights up. You can play around with different turns and different diameters and see what results you get. You can also use a 9-volt battery. I was just using what was available in the house. 1.4 volts works fine. Just make sure if you use 9 volt, use a high resistor, otherwise transistor will burn. You can use a 1K resistor to allow safe current through the transistor. Let's see what happens if I put my hand between the two circuits. The LED is still on. Now it's off. Still on, which means magnetic field is strong even with the hand between the two circuits. I'll turn the lights off again. So my hand is between the two circuits. LED is still on. That's pretty good. The magnetic field is strong. That's great. Hope you enjoyed this. If you've got any questions, put them in the comments and I'll try to answer all of these. Thank you.